All right. Let's keep working on Pro Gymnast. So where we left off on my to-do list here is right. So I've got the level complete sequence working pretty well. Next thing I need to do on it is add these complete cameras to each set. So I've got like the beach environment set up properly. Let's go look at that. There we go. Okay, so the beach is here in prefabs sets environment beach, and I added this level set win cam over here, which if we click on the camera we'll get a little preview here. This is the view it's going to show you when you complete a level, and we have the little replay thumbnail happening. I made this into a prefab, so now I need to drop this into my other sets so that this can work no matter what the background is. So let's add one to the beach pier location, which looks like this. So this one should be pretty easy to add. Let's go win cam. Okay. Add this into the pier somewhere. Okay. Now, probably the easiest way to do this is to get it kind of set, which in this case obviously going to show the like one item in the set here, which is this Ferris wheel. Okay, so with that set, now what I can do is I'll just play, I'm just going to load up a test level. I'm going to set this level to take place in the pier. We'll play it, win the level. Did it not find it? Oh, I think I had a reference I needed to set up. Let's go back. Sets, beach pier. Here, environment set references needs the win cam. Okay. Okay, now do this again. Level data, load level. Let's actually save changing this to the pier. Oops. Save that. Okay. Now play. Catch on. Okay. Now we've got right here. We can go look at this. Go here, and we can kind of tweak this angle now. I wonder. Oh, we're not seeing the ocean at all. Interesting. Oh, this camera. Right. Okay. I don't know if it's going to be worth being able to see the ocean with these win cams. Let's see. I am going to kind of wish they had dipped the field or something on them though. Okay. What do I want to look at? I guess I just want kind of Ferris wheel. I probably don't want this building even showing. Go like this. Kind of turn this a little bit. Maybe point up a little bit. kind of overlapping with the replay editor preview quite a bit there. I could move it over here and look at it from the other way. Whoops. Okay, you just have to be farther than that though. That's pretty cool. Let's say that's it. So we're going to copy this transform. And we can go back to the pier, grab the camera, and paste that. And now we're over there. Okay. Let's set one up for the grid environment. And this, actually... do I have... I do. Okay. This grid is a little bit small. I need to make it a little longer. Like maybe twice as long. And we're going to set this then to be 100. So that the grid lines stay square-ish. Okay. This ought to be a relatively easy one to add a camera to. Yeah, we'll just go over to a corner here somewhere. Okay, and let's add environment set reference to this camera. Okay. Now we're going to switch this test level. In this one, I'm going to switch this to the grid backdrop. Save that. Okay. Alright. And then let's go just make this like angle look a little more interesting. Where is this? Right here. Here. So we could just kind of like could even override the FOV here. Something like that's kind of cool. This is a pretty simple one, so we're going to copy this and we're going to remember that the camera was at 54 degrees FOV. Go back to the grid, paste this, set this to 54. Okay. Now let's add it to the gym. So the gym is this indoor environment, or quasi-indoor environment here. This one, yeah, I guess we could make it like looking out the window or something. Let's add a wind cam. Okay, and add a reference. The wind cam. Okay. All right. Now load our test level. We're gonna set this to be in the gym. There. Save that. And okay. actually beat the level here. Okay, we're just staring at the wall. So, go here to our camera. Where is it? Okay, now this one, the coolest thing in the gym is either like, kind of like looking out a window. Although this camera just has like a generic skybox, I think, set. And so we could do something like that. Or we do something with this foam pit, which is kind of the most interesting. I feel like the foam pit is a better call. So we'll come over here somewhere. Come down. Might even be kind of cool if we're just like looking straight down at it. Let's see, how would that work? That would be like this. Oops. Oops. Oh, that's not gonna work. Okay. I think over the pit. That's pretty cool. Now there's a chance that if you've set up some props and stuff in here, they're gonna obscure this. Best way to combat that, I guess, would be to bring it over like this and kind of angle it. Yeah, maybe a little more. That's kind of cool. I like that. Let's call that WinCam for the gym. So copy this. Now go back to the gym, go to the WinCam, paste that. Okay. Next, this is my Tokyo Bay location. This one should be pretty easy. I'm going to focus on this bridge, I think. So let's add the camera in. Add a reference. Put in the actual reference to the camera. There we go. Okay. Now we'll go here to our test level. Change its location to the one without a proper name yet. Save that. Play. Alright. Now, let's go find our camera. Right here. Okay. Not looking at much interesting at the moment. Okay, this camera can't. I'll have to adjust this. Alright. We want to go like get a look at this bridge that we don't normally get in gameplay, I think. I don't know how close we want to get to it. It's not the most detailed bridge in the world. Also, we're going to need to change the far plane of this camera to be farther. There we go. Okay. So, I think we want more like a... yeah, something like this. Or maybe more of an oblique angle so you can see the bridge. So if we go like here, we turn a little bit. And then classic pan up, drop the height. looks okay-ish. Okay, let's call it that. Copy that. Boom. Go back to this set. Click on the WinCam. Paste. Boom. Alright. And that's all the locations. So that's cool. Added those. Doop doop. Okay, now we do need to do a little investigation into why the post-processing is busted. And the other thing we could do is I could try adding it to this. What is it? Post-process layer. Yeah, correct. Layer is everything. Do I have one for this? Oh, I do. Okay. So put this on nothing, then put this on post-processing. And is that what I want? Hang on. Main camera. Post-process layer. Yeah, okay. And a hydro multi-cam component perhaps as well. Let's try this. And let's move up this. Okay. Okay, let's see if this makes any difference. Okay. So let's load our test level. And let's go back to the beach for now. Save that. Okay. We've got ocean in the background, that's good. Okay, cool. So now the WinCam has depth of field. The depth of field is changing based on the other camera. And we still have some weird, like, it's like fading to white issue on the replay. None of that's particularly desirable. Now what happens if I go to the main camera and I turn off post-processing on it? Now that camera renders properly. Depth of field is not updating anymore. I mean, that looks okay. I still don't get why. Why is this? Let's see, what is this camera's depth set at? -1. What is the WinCam set at? 0. Does changing this do anything? Doesn't look like it. The depth of field updating there is because the Cinemachine cameras are adjusting the target distance, which makes sense. And we already tried this, like if I turn this camera off, turn the whole game object off, it doesn't matter. It doesn't change the fact that that thing is rendering weird. I wonder if the... what did I call it? I wonder if the render texture, this one, has a depth buffer. Of course it has a depth buffer, so that should be fine. These ones. Oh, that's weird. Hang on, why is my 4K render texture not 4K? 4K resolution. (3840 by 2160). Whew, 63.3 megabytes in RAM. That's crazy. Okay. Anyway, back to what I was doing. So okay. Does this use on? It does use on render image. Okay. I gotta figure out how do I narrow down why this is happening. So let's load this level up again. Okay. Because there's not much difference between this screen, where I take this render texture, right, and I draw it into this raw image right here. Oh, it's an alpha thing. Look at this. The texture being produced by the rendered texture has an alpha value. And so I'm seeing through to the white background. Okay. This is vaguely ringing a bell. Okay, what am I doing in the results? Or, I mean, the replay screen. Let's go find that. Game replay UI, image panel, game image, raw image. I have a material that is probably getting rid of the alpha. So if I go here and I set this to replay text, look at that. Oh, I've solved this problem before, and I completely forgot about it. Well, all right. That's good news. And I wonder then, I wonder if I can just put like a fixed depth of field value on this WinCam. Let's see, the way to do that. Okay, well, let's remember this here. So this replay image needs a material, which is the replay text. Met. Okay. Save that. Okay. Now, here's my main post-processing like filter thing. I mean, I don't know if I want 2 rounds of post-processing going on just for this windscreen. This might be overkill. Yeah, so let's go turn that off for now. That's gonna be in prefabs, sets, level set WinCam, go to the camera, turn off post-processing. But maybe leave the ocean. Let's see if the result cam can see the ocean now. Okay, go here, play this level. Gameplay looks correct. Front flip. Yes, I can see the ocean. I got no depth of field, but that's okay. Let's go back here, level data. Let's test the gym. Looking at the pit, zoomed in. Looks kind of cool. Edit, level data, grid backdrop. Play this. Boom. Things are looking good in grid world. Let's load up the pier. Okay. We got the ocean in the background there. Nice double. Oh, look at that. Look at that. Okay. And last but not least, level setting, Odaiba. Play. This is a spotlight level. I think it looks pretty cool. Okay, now we could tweak this kick button because we can see. I don't need to like make the camera avoid seeing the ocean. Let's go look at this camera. Can I? Let's see. Pan down a little. Oh, I've got that island in the foreground. That's kind of weird. Okay, that's the reflection. Oh, why? Oh, I didn't change the, yeah, the far plane. Okay, so I remember to fix that. That's okay. It's kind of showing that the environment's not super high res. Let's come out here a little ways. And what if we like widen this up a bit? Okay. How about that? Yeah. Maybe I'm too close to this thing. This set was not really intended to be seen this close. Like zoom out here a bit. That's pretty cool. Is the camera tilted a little bit? It is 2 degrees. Wait a minute, that's worse. Is it? be 0, shouldn't it? That's super weird though, that looks quite tilted. And it is, I think. Oh crap. Okay, these need to be all 0s. I was rotating the wrong thing. Oh god. And I moved it. Oh my god. Okay. Move the right transform. Okay, now this needs to be flattened out. And then we can pan up a little bit. And over a little bit. There we go. Okay, so I want this location. Copy that. And I gotta remember to set the far clip plane on this one. Okay, let's go back here. Paste this. Boom, go here. Far clip plane, 2000 please. Okay. Is this where, yeah, this is where I have the skybox set. Okay. Alright. Cool. So we fixed the post-processing bug. It was simpler than I thought. Alright. What should I do next? Yeah, let's do something a little more interesting. Let's add a new prop into the game. Alright, so I'm realizing let's go into the game. So I recently added the parallel bars into the game. And the parallel bars were a long overdue realization. So this game is super hard, generally speaking. And the main reason is A, the controls are detailed. Like I can use the what is it here? The left stick to control the shoulders of the gymnast. Right stick, control the legs. And then you got what is it? Right trigger for the knees, or sort of pulling in the legs, right, and left trigger for pulling in the arms. So, you know, fairly co-op-like in the way you have all this control over the gymnast. It means if you know what you're doing, you know, you can easily swing around the bar, you can, you know, let go, do flips and stuff. But if you don't know what you're doing, it looks like this. And that is sort of compounded by the fact that the game is about swinging on bars. So if I make a simple level like this level is quite hard. I gotta learn how to build up swing somehow, right? Then I gotta let go at the right time, and I gotta get my hands onto that little tiny target over there, which is the other bar. Like that. So that's sort of like compounding the difficulty quite a bit. And I'm okay with that. I don't mind the game being kind of hard. That's why all the levels are super short. So that they shouldn't be too frustrating to retry. But still, pretty hard. Now, I had some objects that I was noticing can make life a little easier. Like, for example, the rope. Here it is. So if I had the rope in, the rope, you can grab anywhere along that thing. So the hit target is much more forgiving. You know, like your hands just need to pass through this long line. Which is cool, but the problem is the rope is really hard to get any kind of swing going and kind of progress farther into a level. So I've tended to only put like one rope in the middle of a level, or frequently put a rope as the last object in the level, so that the last jump or, you know, leap is a little more forgiving. The other thing that's been close to that are the spinners. this is basically, you know, a rotating object with 4 bars on it. So it's slightly more forgiving because you can grab any of these 4 spots on it. But it also has the same problem as the rope, which is this, once you're on it, you should see if I can get on it here real quick. So once you're on it, it swings and you swing on the bar relative to it, and it takes a lot of practice to learn how to build up swing on one of these rotors. And it's really hard to go past sort of like 180 degrees here. See? Because you tend to do that. And so these are also really hard. Now the realization was that parallel bars are a really nice solution to a lot of this because they're like a rope in that they have a big region. You just have to get your arms to pass through, right? Like I'm going to catch that no matter what if I just fall generally through it. But they act like a bar in terms of how you attach to them and swing. So you can be much less precise with your jumps, and you can stay alive, you know, and you can make progress through the level. So one of the things I got to do, which I'll probably start doing soon, is I need to go back to a lot of my levels, especially the levels I intend to have earlier in the game, and I need to put in way more parallel bars. This should make the early parts of the game much less frustrating. Oh, I'm also realizing I need to add signal support to the parallel bars. Add signal to the P bars. Okay. Now, so that made me realize I want to try adding in a new prop. A prop that is sort of like this, except without the bars, and you just grab right onto the ring itself, which would make it a much bigger hit target. If you just touch it anywhere, you grab onto it. Now I try and make it that when you grab on, it's sort of a more of a solid grab, so it kind of acts like a big bar as opposed to a rotating thing with a separate bar that you're spinning around. So we're gonna test this out. Yeah, so the way I test out things is I just throw an object into the scene that has some of the properties of a prop in the game, and then I can iterate and test on it, and then when I'm happy I can turn that into a prefab and actually add it into the to the palette of props for the game. So for example, I could go here and go, let's create an empty new game object. What are we going to call this? Call it a rigid rotor. Oh, that's kind of dumb. What is this thing? It's a grab wheel. Right? Why not? Okay. And we'll go here to orthographic view. We're just going to place it, you know, somewhere right here so it over 1 up 2 in the scene. And this is going to have a kinematic rigid body on the root object. It's going to be a basic prop. Okay. And then we're going to give it, just as a test here, we're going to give it a child cylinder. Okay. Actually, yeah. Let's not do that. Let's do this a little more cleanly. So we're going to create new empty. This is going to be the wheel. So this gets a rigid body. Probably has a, it's kind of, I don't know how heavy this should be. Let's set it at 5 kilograms to start. And it's going to have a configurable joint connecting it to its parent, like that. And then this thing's also going to have a sphere collider, I think. Okay, now let's give it some visuals just to, so we can see this thing. So we'll add a cylinder. We'll call this mesh. Get rid of the collider. Rotate this 90 degrees. We're going to set this to like thin. Alright, so this is our thin wheel that has a sphere collider on it. Cool. This whole thing should be on the interactable layer. Alright, now this configurable joint, I want it to work like a hinge. So we want the main axis to be in the Z direction. I don't really care about secondary axis. Motion about, well, it's locked. All motion is locked. Angular motion around the X, which X in this case means the main axis of the configurable joint, that's gonna be free. These other two are gonna be locked. So this should now be a rigid hinge that connects this wheel to this other rigid body here that doesn't even have a collider. It's just a holder for it, essentially. You don't have to do that. This could just have nothing set and then it will connect to the world, but these props get added and moved around, and it's generally what can happen then is that this connected anchor can get out of sync and it'll think it's connected to some old position after you moved the prop or something. So to solve that, I just put a kinematic rigid body that it's attached to. It's also a part of the prop. That seems to work pretty well. Okay, so now if this, right, let's just run this. So now what we should have is just a annoying little cylinder in the level that I can collide with, and you can see it rolling there. So I got my hinge set properly. It's kind of funny, actually. I should make like a little roller slide. That's a cool idea. I'll have to add that. Like one of those like slides that's like it's like a long thing with a bunch of little rollers on it. Like you see, it's like a playground or something. That would be pretty fun. Okay, so now we need to make it so you can grab onto this thing. So we add, as a quick test, this is not going to be good enough, but if we add a grabbable, actually, grabbable ring might do it. Let me think about this. No, that's not what I want, actually. That's for the rings, which still have just a single fixed grab point. So we're going to need to make a script for this in a second, but for now, let's just try this. Now what this should do now is essentially act like a huge bar. Now if my hands touch this thing, we're going to attach to it, but they should pop to the center when you touch it. Yeah, it's trying to pop to the center, but it can't because it's colliding with the rest of the gymnast. And so, right. Now we can fix this by, if we set the wheel to be on the interactable hand only layer, now this thing will only collide with the gymnast's hands, which will mean it's there. Now this is not what we want probably in this case, because if I go like this, I'm going to fall through it until my hands touch it and then they attach. Now essentially I just made a bar. Not particularly exciting. So let's try. Let's put this back on the normal interactable layer, and we're going to make a different type of grabbable, right? Because we have segment, ring, yeah, and parallel bars, none of which quite do what we want. So let's go find grabbable. Where's this thing? Here it is. And we're going to add a new script called grabbable wheel. Okay. So grabbable wheel is a grabbable. Uh-oh. My autocomplete gonna be broken again? It's so annoying. Grabbable. Alright, so all we really care about is overloading some of these functions here, and particularly this one, the get grab anchor point. So I think what we're going to do is we're going to override that. And what we want is a wheel where you can grab anywhere around the radius. So we can have a radius value. Yeah. So now let's add a little gizmo so we can see this. And do I have a... easy way to draw this? Let's see. I mean, I guess we just do this. The transform dot position m radius. Let's default this to 0.5. Okay. Alright, let's quickly go here. Now, look at our wheel. Compiling. Okay. And then this is going to have a grabbable wheel on it. Alright, and now we're drawing a circle on there. So you can see this is the grab radius. And we might want it to be just slightly smaller than the actual wheel. So let's do 0.475. And now what we're going to do, so we get the position of the hand here. So we want to do return closest point on the radius. So what we're going to do is we're going to turn this hand position into local space. And we actually want to return a local, this wants a local space value for the return point, so that's good. So we're going to inverse transform the hand positioned. I'm surprised I'm passing that in the vector too, but the physics, or the gameplay is 2D in this game, so every now and then I'm thinking about things in 2D versus 3D. Okay, and since we know that about our game, we don't care about the Z component of the hand. So just to be safe, .z, zero that out. Okay, now basically what we want to do is we want to the hand's position now, right, is pointing. Like if you go from the origin to the hand position, that is a vector going out, and we want to make sure that the length of that vector is radius. So we're just going to do local, we're going to do return local hand dot normalized times m radius. Okay, so now what we should have is that no matter where you grab this thing, and no matter how it's been spun or rotated, like let's say the hand, you know, like overlaps slightly and actually grabs here, then we're going to turn that into local space here, and we're going to shoot back out to this point and attach the hand to there, to actually radius distance, which is what, 0.475 currently. All right. And let's test it. Okay, first of all, we can collide with it again, right? We can, and we can catch on to it. Look at that. Okay. Right. Okay, so let me try something here. If I grab it a little more like where we want to. Okay, it's a big wheel we can grab onto. You do, you know, still kind of you know, for this to work like the way I want the gymnast like grabbed onto it, like they're holding onto it really tight. So it's essentially your arms kind of stay perpendicular to it, which I've kind of got here, except you have to grab it nicely. Otherwise, you get stuck. Like if I grab it like that, well, maybe not. Maybe that's okay. I think it's just that if you grab it like with your hands kind of upside down, you get attached onto it a little weird. Right. Now that's because I have this drop down you can see here called grab type, free spin, loose spring, hard spring. What that does is a little weird, but let's go look at it because it's been a while. And it may be time to improve this a little bit. So if we go find the references of this, the gymnast essentially here. So when we are grabbing onto a grabbable, you can see what we do is we ask the grabbable, where should we attach to? That's that code I was just writing. Then we create a hinge joint. It's a hinge joint. That may be part of my problem. I have to think about that. We create a hinge joint, and it's on the hand, centered on the hand, and it's attached to the other body. And the connected anchor is put into local space there properly, just in case the grabbable transform is different than the body, which is like the case of like those rotators where there's several grabbables attached to it. Okay, now in a free spin scenario, or in a non-free spin scenario, excuse me, we add a spring onto this joint. And I've got two settings right now for like a loose spring and a hard spring. They just change the power and damping of the spring. And then here's where I try to align it. So this is making an assumption. Right. Yeah, I'm trying to work out here the angle between the hand and the grabbable. Okay. So that I can set the target angle of the spring. I love it. Look at this down here. Hack question mark. That's okay though. This is making sure that the hand and the forearm do not collide, because the forearm's like really close to the hand, and so if that thing's constantly fighting with the thing you grabbed, it's annoying. This is mostly for the case where I still want the body to collide with the thing you grabbed, like a bar, or in this case like this wheel. Okay, so I think what I need here, so this assumes, it's the grabbable transform.write. So if I go look at, like for example, the trapeze, which is where I started wanting some of this like not free spin code. Let's go look at this one. So if you look at this, is this the one with the grabbable on it? Yeah. It's so it's, you know, transform.write, which is this red line is pointing out like that, and that's because then I can I know the way the hand is oriented, and so I can calculate the angle between those two, and then say, oh, well, I really wish the hand was perfectly aligned this way. And then I have a toggle here that says, oh, actually, allow upside down I've removed. Okay, well, I'm not worried about that too much right now. So that works for something you're grabbing onto that has a fixed orientation. But this, this wheel doesn't. So I essentially need a way to override this. Yeah, now let's go look at the, because I think the reason this is off in this direction is, and this one's probably set for, let's go look at this actually. Loose spring, okay. So the main gymnast, if we go look at the hand, yeah, see, so the right, you know, the plus X direction on the hand is this way, which makes sense because if we were hanging from the bar, that would be pointing over to the left here. And so that's why the trapeze are set up with that point to the left, so that those two orientations are aligned, and then, you know, so when we try and create a zero rotation between those, we know we're making you hang straight. So what this means is that grabbables that are using springs want a vector for the target rotation that is kind of like tangent. Okay, so what we're gonna do is we're gonna add something to grabbable. We're gonna give it another virtual, which is the get grab spring basis direction. And in this case, let's go look at gymnasts grab. Oops. Okay. What we want from this thing right here is a world space, direction. Okay. And so the default behavior is going to be to return transform.right. And now we could go here and say grabbable basis dir equals grabbable dot oh my god, lovely typo there. Get grab spring basis direction, so this should be get. Okay, and that's returning transform.right, which is what we were already doing here, but now we can pass this in. Grabbable basis dir. Okay. And most of my grabbables I've already made, we'll just leave alone because they want this default behavior. But the wheel wants to be clever. Okay, so the wheel, wherever you grabbed onto it, we want a thing pointing, we want a tangent. Okay, so I actually need to know where you grabbed onto it though for this to work. I'm not passing anything into this. Let's... What do we do? We could... I mean, in the case of the wheel, we could remember where we grabbed and use that here. That's the simple case. Let's do that. Okay, so vector 3 m local grab dir. We'll keep this a normalized value, which is right here. This is local hand dot normalized. And then we can just return that times radius. Okay. And then what we can do here is tangent to grab position. So this is going to be tangent equals the cross product of our grab dir and forward, except we're in a weird space right now. This needs to be in world space now. Right? Yeah, so vector 3 world normal equals transform direction local grab dir. We want to cross between that and forward. And we're going to return that. Now let's draw this. To help draw this, I need to grab the grab point in world space. World grab equals transform point m local grab dir times m radius. Okay, so now we can do debug.drawLine world grab comma world grab plus tangent. This is supposed to be red, right? Why not? And let's draw that for like 5 seconds. Okay. This needs to be an override. Okay. Alright. Now... this is all still set up correctly, I think. Okay. Okay, simple case. And we actually want to watch this happen in the scene view. Okay. Okay, so I think... so that's that red line right there. It's definitely tangent, which is good. And is it the right direction? Maybe. Let's try grabbing it like this. Okay. So that's good. The hands are kind of staying perpendicular. Like if I go like this, the gymnast is hanging on to that brain and keeping his arms kind of parallel out, so that's good. Now, what's the weird case where the hands would be like almost upside down? It would be like if I start like this. Oh, I'm overlapping with it. That's cool. Okay. Right, because you can glide with this thing. So actually, yeah, let's do this. Let's like sit on it. And then grab it. Okay, well that's probably going to work. That's not what I wanted. I wanted to grab it like that. Ooh, that's correct. See, look. Boom. I have to unfold, but... hey, cool. Okay. Now, let's just try like a... Oh no, I'm not gonna make it back to the... okay. These are way easier to spin around than the other rotors, so that's exactly what I'm hoping for. Oh, why did I fly off there? Okay. Let's try a release and catch back on. So I could even just go whoop. And see here, if this had been a bar, probably wouldn't catch it again. But because it's a bigger object, I can catch back onto it, so that's cool. I could make a bigger version of this too. I'll probably make a couple sizes now that I've got it working. It's kind of cool to collide with it and then catch onto it. Cool. Alright, so the next step for this is going to be to make some visuals for it and to turn the hands so that they're grabbing onto it like this. I think I'm going to make this like have a ridge, kind of like a thing that you can see how the gymnast could kind of grab onto it like this. So that should be pretty easy. I just have to rotate the hands and then make a couple sizes of this, and this is going to be a cool new prop. Grab wheel. Alright. Good progress today. Trying to keep my dev on this game to hour stints. Oh, sorry, I'm just noticing some chat here. What are you using for the physics? So this is, since I'm using Unity, this is all basically using Unity's physics. So, you know, using rigid body components and using their solver. So luckily I don't have to do a lot of complex, you know, physics math or anything. Mostly what makes this game interesting on top of that physics is the settings I'm using and the tuning. In particular, this gymnast. So this is the actual physics model for the gymnast. You can see it's this weird, you look at it this way, it doesn't look like a person anymore because it's 2D. I am using 3D physics, but I'm constraining them to 2D. And basically you have rigid bodies for each major body part. Like here you got the torso, pelvis, femur, calf, foot, toes, upper arm, lower arm, and hand and head. And each one of these has, first of all, it's in meter units, so it's fairly realistic in terms of the units. Like the gravity constant is their normal 9.8. And then the masses on these rigid bodies are somewhat realistic masses based on the overall, like, you know, number of kilograms I wanted the body to be, and then the kind of relative density of each part. And then they're all connected together with joints. In this case, Unity has this thing called configurable joint, which I'm not exactly sure what that's called down in physics land. Right. Yeah, physics works just fine in 2D, just need the right initial conditions and choice coordinates. Yeah. And, you know, this is a full 3D physics engine that I'm adding some constraints to make it basically simulate a simplified 2D character. And the main thing this game's got is these, where is it? Like, for example, this is the connection between the torso and the head. And actually, you look here, I've also got a connection here between the torso and the upper arm, and torso and the pelvis. And here, there are essentially spring forces between each of these rigid bodies. And I've got a script here, is it? No, right here, gymnast joints. So here is the main data of this game. And this basically says like, hey, the neck joint, how strong is the spring, how much damping does it have, and what's the maximum amount of torque that can be applied to that joint. And I have that for all of these. And basically I tweaked these numbers until I got a semi-plausible gymnast where the strength of the joints seemed, you know, plausible in terms of what the gymnast is capable of doing. So, and then what I do is I map inputs from the controller to target angles for these joints, but because they're limited by their strength, and particularly this max torque value, the gymnast can't just immediately do what you want, and so there's a little bit of a delay and strength that comes in. So then you have to actually use techniques like swinging and changing the size of your body's moment of inertia by tucking or straightening out to control the gymnast. So that's the basics of it, but luckily I don't have to do a lot of the actual, you know, like kinematic or collision math myself that comes from Unity's physics system. The other big thing is that Unity has some strange defaults. So if I go here to project settings, if you look at time, one thing is that I have a fixed time step is essentially like what's the duration of time it's going to simulate the physics, and I have this at a very low number, so I update the physics quite frequently, which allows the simulation to just be quite accurate. It's expensive, but I don't care in this case because I don't have a lot of objects in the scene. So that's a huge change there. And then also, I think I have tweaked some of these. Yeah, so these are the different settings for the physics solver. And I have definitely cranked up the number of iterations. This is mostly because I have a lot of connected joints, and so, you know, problem can happen where it solves one joint, and by solving that joint, it sends another joint out of, you know, equilibrium. So it does 12 iterations on trying to solve all the joints, then resolve them, then resolve them, then resolve them to arrive at a solution that doesn't have the joints getting out of whack. And I think those are the main changes I made. Yeah. Yeah. So that's the basics. Alright, so we'll come back Monday and we'll turn this new prop into something with some visuals and get it integrated into the game so you can add it into levels, and it should be pretty good. And thanks for tuning in. See everyone next time.